Hello friends, welcome to Tech Rabbit. Today we will talk on OLS, that is ordinary least square regression. So OLS, these are the content I am going to explain in the next slides. So OLS we will use it for regression analysis, that is it gives the relationship between input and output variable. OLS we can use it for the univariate analysis, also for multivariate. Univariate means which having a single input variable and multivariate has multiple input variables. So let's take a x and y coordinate system. We have a few points that is highlighted with the blue dot. These are the actual values of y which correspond to x value. X we will call as the input variable and y we will call as the output variable. So we want to find the relationship between x and y that gives the minimum error along the line. So these are the actual value and purple line gives us a predicted value. So if you want to take a vertical distance, that gives us an error. And in this OLS, if you take summation of errors, it gives the value approximately to 0. Okay, so that means the error, it is distributed normally along this line. I will explain what is error in the next slide. So the line which cuts on the y-axis is we will call as a bias and we will denote it as a C. And this relationship line, that is a regression line which makes angle with respect to input variable, we will call it as M or slope. And this is the error which gives the difference between actual value and predicted value. The equation for the predicted line, that is which gives the relationship between x and y, is given by y hat equal to mx plus c. We will call y hat for predicted value and actual value we will call as a y. Here I have given a nomenclature that y is equal to dependent or output variable, x is the independent input variable, y hat equal to predicted value, and m equal to slope, c equal to bias. OLS is used for regression analysis. It gives relationship between one or more input and output variable. One input we will call as univariate and multiple input we will call as multivariate. Okay, so assumption here is we will the relation should be a linear. Okay, and errors are normally distributed. So if you take a summation of all the errors, you will get value equal to 0. That means those are normally distributed. So what are the steps to solve the OLS? We have input values and output values. To get the predicted value, we have to get the relation between x and y. We know predicted value equation equal to mx plus c. Here m as a slope, c as a bias, and x as an input variable. Okay, slope has a formula that is covariance of xy divided by variance of x. So this is the formula for covariance and formula for variance. Covariance is a summation of x minus x bar into y minus y bar divided by n minus 1. Similarly, for the variance, we have formula that is x minus x bar bracket square divided by n minus 1. Similarly goes to variance of y, that it will give y minus y bar bracket square divided by n minus 1. And equation for the bias is c equal to y bar minus m into x bar. So y bar and x bar are both average values. So let's understand with the help of example. Suppose we have x and y values, 2, 3, 4, 5 are x values and y values are 1, 3, 5, 7. Okay. So if you want to draw a graph, it will look like this. So this is the graph for x and y values. To get y predicted, we first have to find out a few parameters. That is, first is the mean, that is average value. We will find out like 2 plus 3 plus 4 plus 5 divided by 4, we will get 3.5. Similarly for the y values, we will get 4. Next we have to find out the variance. Variance, I already told you the formula. The same formula we will put it here and we will get a value of 3.5. Just like a variance, we will find out covariance. So with this formula, we can get value of covariance is 3. To get the predicted value, we have formula mx plus c. Slope has a formula covariance of xy divided by variance of x. It gives answer 2. Similarly, for the intercept, we have formula y bar minus m into x bar, which gives answer of minus 3. We will try to put these values of m and x in this formula for all the values of x. So we will get output value, that is 1, 3, 5, 7. The formula for the error, that is y minus y hat. If you closely look at the values of y minus y hat, both are similar. So that means error is equal to 0. So let us try to put this all the values of slope, constant and y predicted values on graph. So this is this red line which gives the relationship between the x and y values. Here you can see intercept, that is the bias of -3. So this is bias and the slope as a 2 with the relationship of x and y. Suppose let's take value of x as a 6, and to find out the value of y we can put this slope and constant. So 2 into 6 minus 3, 12 minus 3 is 9, so plus 9. So this is all about the ordinary least square regression. We have only considered single input and we found out the relationship between input and output variable. So hope you like this video. Thank you.